Welcome everyone. Today we have Andrei Lopatenko as our speaker. He's VP of Engineering at Zillow Group, where he leads the teams responsible for the company's search and discovery engines, including search science, development, infrastructure, and operations. As part of this role, he heads Zillow Group's conversational AI efforts, which consists of initiatives around natural language processing platforms, speech analytics, call center AI, and conversational interfaces, with the goal of improving Zillow's business and customer services using NLP and speech understanding. Before joining Zillow in 2019, Andrei led search science teams within eBay and Walmart and worked at Google and Apple, serving as a core contributor to their most popular search products. Andrei earned his PhD at the University of Manchester in the UK and his master's at MIPT, Moscow Institute of Physics and Technology. So please take away. Thank you.
Hi. Good morning or good day, everybody. It's very nice to meet you, to talk with you. So my name is Andrei Lopatenko, and I would like to present this talk about natural language processing at scale. It will not be only about machine learning operations. It will be in general how to build and design and run natural language processing systems at scale within companies for business and customer experience. But I will show that machine learning aspects are quite important. Let me make a presentation here. What I will focus on this talk. I will talk how to implement and use natural language processing within your organization at scale, and I will explain what this means at scale for large business impact with low development infrastructure cost, how to solve many different business problems with NLP, improve customer experience, and how to build an NLP development process ops serving your business. What does it mean at scale? So I mean there are two very different notions, both of them actually are quite important. One is how to scale natural language business, like processing systems by business task, how to apply them, and it's typically in every big company now. You can get huge advantage, monetary, financial, customer experience, not just by using NLP at one particular system, but running it in multiple different business tasks. And another is how to scale by size of data, by a high load of number of users per day, per second, depending on your system, number of documents per second, number of documents in process. So there are multiple different dimensions of scale here. Doing it right way makes high return on investments. And I would advocate on this talk, like I'm building systems for many years, that now it's relatively easy. There are many open source tools, there are many cloud tools, there are many other different ways how you approach building, training, scientific workbench, inference parts. So now building NLP systems at scale is quite a relatively easy task. With small investments, you can get big results. Why I'm talking about this? So I'm building NLP since 2006. It will be, 15 years by now. In every search and other business tasks I was busy with. I was co-contributor to Google Search, Apple Maps, App Store Search. I was founding engineer of Apple Maps, started when it started the Walmart Search, led Walmart and embedded search science teams. Currently leading Zillow Search. I was founder of a startup which we sold, was acquired by Facebook in 2017. It was NLP heavy startup. And in every organization I work, NLP was one of key technologies driving business and customer experience. So of course, every search application is heavily based on NLP to understand queries, to understand documents, but also NLP has impact much beyond that, driving whole business. And then of course, like many other applications. So and 2021, due to abundance of NLP tools from development to serving, building big impact NLP systems is more available than it was several years ago. And I would like to share my experience how to do it. Motivating examples, several motivating examples why NLP is useful in very different cases, right? Typically, if you read like popular media now, everybody talks about NLP, mostly in chatbot context. It's a very small part of applications of NLP and certainly not the most financially rewarding at scale. So we will talk about very different systems. So search, of course, any search would be like Google or any other big search engine, Amazon, Walmart, what I was working, App Store. Of course, understanding query, understanding semantic meaning of the query, extracting a lot of information from query and documents are really important, right? Like BERT, like recently it was an announcement, it's improved radically Google search, but certainly I know like Google search is based on NLP for many years. It's one of the key parts always, right? There are many different techniques, synonym expansion, term weighting, shallow parsing, and many others which drives any big search for many years. years, and that like NLP for online search applications is one of the big NLP use cases. And then another very important one, also like similar to search, question answering, more like business facing than customers, but also customers. NLP is like natural language interface to unstructured text information, like frequently asked questions, right? You have huge amount of information about policies of your companies, like assume for retailer, like for e-commerce, what a return policy, how like, or for airline shopping, like what your policy regarding my luggage or whatever, right? Question answering, like users don't need to go through this, like like thousands of documents. They can ask question and get right paragraph, or access to structured information databases, like typically for business intelligence. Natural language interface to databases is another big NLP application and quite business rewarding currently. Another analysis of conversations, real-time streaming. There was this fascinating example. It was school project, like prioritization of emergency dispatch calls. Like three high school participants in Bay Area built a system to analyze emergency phone calls and assess their priority, right? To understand how important is this, how it was school project, but it's like like very impressive that actually high school students can build a cost prototype system pretty rapidly. And now, so like there is another example, a European company deploys a real time, so it's called Corti company. Then analyze calls and detect cardiac arrest. It's not NLP, it's more like voice analysis, but it's very neighboring area, very close area to NLP, and actually systems built as a same. You can sort voice analysis at this point after you get transcription, or you sort NLP analysis. So understanding phone calls, transcribing them, assigning quality of service, needs of customers, understanding needs of customers, performance of customer support, getting customer insight, quality of business agents is another popular application, and there are many companies working on this, on analysis of calls online or near real time. Customer support dialogue systems, chatbots, like if you use Amazon customer support, it's typical NLP system serving for that, right? Reporting problem to Amazon, and there are many other companies. So like customer support dialogue systems. So like I don't like word chatbot in particular. It's like very popular now, solve a lot of problems, like cut a lot of costs. Another typical example of NLP. And then our typical item understanding, right? If you're a merchant, you get a lot of descriptions of item or whatever you do, like what would be e-commerce, real estate, you have full text descriptions. How to get deep understanding of the item based on full text, right? You don't get database or like structured feed always. And extracting NLP insights based on full text analysis is another popular application when NLP applied at scale with big business advantage now. So basically, what I was showing in these examples, right, that there are multiple very different cases, very different from business point of view, customer point of view, serving systems, like one you have to do online serving, another you have to do batch processing, another streaming service, where NLP is applied for big advantage. And there are very different ways to run it. Online, streaming, batch processing requires very different type of systems, but like it's good that MLOps actually can be quite, MLOps stack can be quite shared across these very different systems. Most of media hype now, like is about chatbots. Again, they're not the biggest application. Most of in 2021 actually business impact NLP in other areas, but the conversational systems has a lot of gain also, both from customer experience and business impact, right? Like billions of dollars in better search recommendation personalization based on NLU, hundreds of millions of dollars in document understanding, better classification, information extraction. So those are big impacts. So there are like three key serving scenarios, right? Typically arise once you build such systems. Again, it's not full coverage, but kind of typical online scenarios like search, right? A user comes with query, you have to understand this query. You have to provide, and typically it may be up to hundreds of models, different insights, right? You have very short latency times, like 50 milliseconds. You have to run your NLP stack. You have up to 10,000, 100,000 queries per second, right? So those online scenarios. And with a business facing, like question answering typically has, of course, smaller query per second latency times, but also there are some other how we want to serve the systems. Streaming scenarios, you have to process documents as they come, 100 millions per day, maybe. And batch scenarios, you want to process large batch of documents. It can be billions of documents depending again on your business. So like NLP is not just about training models. it's in research papers, it's about building systems. And there are several important stacks to be covered. One, you build systems like serve models in production, train models, annotate data, deploy models from lab to production, test models, validate models, monitor models, integrate model serving with in-stream or production data, integrate with outstreams, consumer business-facing applications, and like all of this, actually I had to emphasize, all of them are related to MLOps. All of this part of NLP stacks is important to include in your MLOps systems. Like majority of big business revenue and customer experience gain from NLP are not just from using the best recent like published state-of-the-art systems, but from the best engineering, high performance, reliable, robust, scalable systems which are integratable with multiple business and consumer applications, right? So most of NLP currently is about building systems fast, high performance systems, reliable, integrating them. It's the most important part why like important to build good MLOps operations for NLP. And then once you build systems, when you run multiple business use cases on this, prove the value, like state-of-the-art model becomes more important, and then you focus more on model improvement per se. Very important, like typically kind of NLP systems, you can see this typical multiple big part, right? One is scientist workbench, everything how to make your model. It goes to access to data sets from large corporate. Sometimes you have to process, like billions of documents from web, right? Or hundreds of millions of documents describing your items, right? Or you have to go through your search logs, which creates like if you want to do a large period of data, up to 1 trillion of events. Annotation tools, data processing, and data management. Metric tools, like you want to keep multiple metrics, how to share them within organization, model training, tuning, model management. This I would call scientist workbench, which not serving in production, but everything regarding analysis, tuning models, creating models, reusing data, creating metrics, so on. Deployment tools, of course, like how to validate models, deploy it into various different environments, integrated with your CI/CD pipelines, model management. Of course, inference is critical, right? Model workflows, monitoring, alerting in production, online validation, continuous validation, performance measurement, observability, both from like software performance point of view and other software parameters, but also from machine learning accuracy, also parameters. And then, of course, like hardware allocation, scaling, like how to scale multiple GPUs, assign them to your models as you increase number of models or number of data is coming, and then integration with in-stream and outstream data. So those kind of big blocks of NLP systems. Again, not comprehensive, but most critical typically. And how to build the systems, right? There are like 3 ways. Again, not comprehensive, but like big blocks. You can do like cloud native systems. I will give a little bit more details. Build the system using standard cloud components very fast. You can build with minimum development efforts, but there are some trade-offs. From scratch, you can write your own system from completely zero, maybe reusing a little bit of open source software, and or like hybrid. Using some big open source and cloud blocks. I will go into details for certain tasks and custom build systems for other tasks. So cloud native, right? So now major cloud providers, I'm talking mostly about Amazon because I know them, but Google and I believe Azure does the same. Has like really big infrastructure to build your NLP machine learning services. And at different level, right? You have comprehend, like to go particularly in NLP, SageMaker ground truth for annotation, transcribe. If you're going through voice and want to put into text, it's like text analytics, Lex, texttract, many different parts, right? What's good about this, it's very fast to develop prototype and make working systems. You can literally in like days make something quite big. Low development cost because of like people can do who knows this very fast. Is integrate with other systems on the same cloud. If they like to integrate with Redshift and so on. Low cost operations for managed solutions. Low cost operations in the sense of human costs, right? What are the cons? Of course, usually like if you build on this very high cloud and compute costs comparing what you built, like utilization of cloud, if you build them directly. A low flexibility in types model to develop and opportunities to develop high accuracy models. Performance is not typically not optimized. You can build much better performance on your own, and integration with non-cloud systems is hard, right? It's for cloud native. Advantage fast machine learning ops pipelines development. There are plenty of tools which are within this ecosystems, like For AWS, you have cloud formation, code pipeline, code build, ECR container registry, SageMaker, like AWS batch is quite like powerful tool for batch processing. So like there are SageMaker pipelines, new tools. There are more high level. So like there are plenty of tools to build what you want to build on such systems, and very fast, right? Another advantage, reasonably easy to adopt to your environment. So they have all these tools, like like if you want to use Terraform instead of cloud formation, you can integrate with those. So it's like there are some certain advantages in building these systems. Again, easy to build multi-environments deployment scenarios if it's integrated with that cloud, right? So once you operate within this cloud, this is quite good tool to build something very fast, very cheap development cost, of course more expensive operational and serving cost, but this is good way to prototype. And sometimes actually you can move this beyond prototype. Build from scratch is another solution which we were doing typically 5-10 years ago because there were no good machine learning NLP infrastructure, right? And it's still good to do now for some certain types, right? What's good about this, so like you don't need to build everything from scratch. You can build on top of some open source. There are a lot of abundance of open source now, PyTorch serving, TF serving for serving, Hugging Face for particular big set of NLP models for different tasks. Like Allen NLP lab environment, good to build on this your own lab environment. Basic kind of getting outdated, but there are a lot of other NLP libraries. If you want to build annotations, it's not necessary to go to SageMaker ground truth and pay for this. You can build on Docana and so on. More opportunities for optimization and accuracy of, like what advantage? More opportunities of optimization for accuracy of models and performance of systems. Customization for your company needs, owning the software. So frequently it's like really core part of business becomes which you want to own. Of course, cons, longer prototype and production development times, high operational support costs instead of like not cloud costs, but like people to support operations on these systems. Sometimes it's necessary, right? If you build your search stack, again, it requires hundreds of models sometimes, right, for build systems, multi-gigabyte dictionaries for some of them. Like complicated dependencies in some models have to be run consecutively, some can be run in parallel. Sometimes frequently you need to run specialized hardware, not just GPUs, but like flash drive storage, nodes, right? And you don't have really good systems to orchestrate running of hundreds of models which dependent on each other, running with like, you have to run all of them within 50 milliseconds. You have to deploy this such that you can run 100,000 queries per second at scale. So there are no really good systems. So such systems you have to build from scratch. There is not much of option I see now. I'm not aware about any case when open source would be adopted for this case. So sometimes you have to do this. You have to take this trade-off and build your own MLOps for this from scratch. And then you have NLP systems, which is mix of cloud and custom build. So there are a lot of like solutions, good solutions for serving, like SageMaker, AWS Batch, Elastic Inference, right? Some of them like quite low level. You can build like your serving scenarios based on them. Yeah, there are some good open source like Kubeflow, and it's supported by AWS. You can do all of this. Again, it's kind of intermediate between first level, what to describe, full cloud blocks versus your own development from scratch. It's quite rapid development and deployment. Of course, will require a lot of tuning, but like once cloud costs higher than like, so it's in between, right? Those cases, cloud costs are higher than in build from scratch scenario, but less than in cloud native scenario. The development costs are opposite. It will be cheaper than build from scratch, but also higher than in cloud native scenario, right? Again, there are multiple scenarios of deployment. You can use this. You can use like if you want to Kubernetes, you can go as a managed or your own. Requires support to build custom expansions. Like for example, for Kubeflow, you will not have all operators for all serving you need, right? And sometimes you need to build your own operators. And there are many high-level tools are available. So this is like very flourishing area. Of course, many of these tools are not mature, require a lot of tuning, like building your own. But there are different types of stacks to build your MLOps operations. You have Kubeflow for like generic. You have Cortex. You have Hydrosphere for managing monitoring models, Seldon for serving, Neptune experiment management, MLflow experiment, model data training, deployment, model registry, Comet. So there are, like if you consider this whole stack of your MLOps, you have multiple different systems. So you don't have really full, there are many solutions which advertise them as comprehensive now, as really, but you can fill a lot of gaps here and there. There are a lot of low-level tools, right, which you build on top of this, like from orchestration to metrics monitoring management, right, and you build your stuff on top of them. So there are a lot of open source to be reused and useful in this context. Just example, Kubeflow is one of those systems which has a lot of stuff in that, right? It's not good for building like online low latency, high through output scenarios, but it can be quite good for like streaming when you need to data coming process. Like it has Kubeflow pipelines, end-to-end orchestration of pipelines. It has like for serving, TF serving Seldon, for data science part, like Jupyter, like cloud notebooks, super useful, Katib, hyperparameter tuning, integratable with TensorFlow model analysis, TensorFlow transform for data operations, and compatible with PyTorch, TensorFlow, MXNet, so that you can build quite good machine learning systems, and particularly for NLP based on that. Again, very important to consider scalability once you build the systems, right? Like how you want to build it scalable, and it's very important for once you build big NLP systems, right? Typically, like I get this errors when you build for a certain load, and then in 1 year discover that you have 10 times more users or 10 times more QPS or 10 times more data, and then you have to return your system. So it's very important once you build this, build scalable by design from very beginning, right? There are multiple areas typical for NLP. Scalability by number of human languages it will serve in future, right? And by domain area languages. So it turns particular part of business, but then actually it expands to other part of business that have own, like within English, like e-commerce can be quite different from, let's say, other parts, right? It's very important that your system is scalable by different domain areas. And serving multiple models if needed, tuned for different load. Of course, QPS online systems, how queries per second for online systems, number of messages per second streaming, the number of documents in batch, and the number of batches in batch system. It can increase again, like as your business scale, as your NLP impact scales to multiple parts, lines of business, it can increase many times. A number of different models, a number of different types of models you want to serve is also quite important, right? You launch some particular NLP models to prove that it gives a big value for the business, and then you have like 50 different use cases where NLP can be applied. And now for each document, instead of 1 or 2 or 5 models, you have to run 50 or 100 models, right? How make systems such that it will scale by the number of models to run in parallel, right? And there are different aspects of this, how to make good performance with the same, from a hardware allocation to like other optimization methods. Number of developers working simultaneously, right? So you have like several people submit their models, and now you have 50 people submit their models. How to create good such that they can reuse their models, but such that they can also submit models without conflict with each other. So like scaling by number of developers. Number of metrics, system is monitored and models are monitored for. It's also quite important consideration. Amount of data for training and serving can increase hundreds of times, right? Again, number of cases, number of deployment scenarios by data centers, regions, like your environments can cases when you start your NLP system, and then after 1-2 years it's used, you might have, instead of one environment, you have multiple staging environments, multiple testing environments. So this is important to put inside your system scalability by design. Again, like I want to emphasize, it's very important there are multiple, for NLP in particular, there are multiple very different serving scenarios, right? And I've never seen that one system would serve all of them, because if you want to serve 100,000 queries per second with 50 milliseconds per each of them, versus you want to process 100 million of documents coming per day, and those are big documents with like 10 kilobytes each of them, and you want to extract a lot of information. But again, it's not critical for you to process each document within 50 milliseconds. You just want to be sure that all the document processed within certain period of time reasonable, right? And you don't have much delay. Or you have to process in batch, like you extract something from your several billion of documents, and then you have a new model, right? As the improvement of previous one, you want to rerun. Or you have a new type of extraction and want to process this billion documents per day. Those are very different serving scenarios, and there is no one good system to serve all of them. But what's important is that science part of this is actually quite unifiable. So you don't build one serving system, but you can build quite a lot of shared components across science. And then again, from traditional MLOps, like monitoring, assessing quality of models, there is also a lot of shared components across these very different serving systems. And you can build also quite a lot of, like MLOps is not like one unified big block. It's a lot of sub-blocks for different scenarios. Some of them reusable, some of them good for particular systems, but it's good by design, built many of them like model assessment quality to be reusable across many different scenarios. Ops, like continuous retraining of models when needed, and there are different things why models need to be retrained, right? Just because you have data typicality shifts, data change over time, like you find better ways to train models, better tuning of models, other hyperparameters, or better procedures you want to retrain your model, even with on the same training and testing set, and then deploy it. There are multiple reasons why you want to continuously retrain even existing models, right? And then, of course, to support your data, your scientists, very important to support like the deployment of new models, the tuning models, and so on. So it's very important to have a good science operation to support frequent deployment of models into production. And it's important to have smooth integration of NLP scientists workbench with production environment, such that models, once it's trained, evaluated, validated, can be easily deployed. But it's very important at this moment to have all these validation steps, not just manually run, but better automatically to understand, does this model bring gains? Is there performance problems from software performance of view, like to long latency time or not, or the same from machine learning accuracy point of view, and then again, scale it by number of models run in parallel and other load parameters. Very important to monitor models for performance continuously, and typically I've noticed many MLOps systems, they focus on running evaluating model performance per se, but actually it's very important to understand end-to-end system, right? Not just how well your model is extracting noun phrases, right? Or how well it's more than making semantic tagging. But if you consider end-to-end, like how many users like the result, did they click or not, did they buy or not, how model affect end-to-end performance, this is like super critical part of NLP operations. So monitoring what's going wrong, right? Model performance, end-to-end operations. When global data changes, and they always change for every NLP systems, like other global shifts, if you're doing e-commerce, like how people search in summer is very different in winter, then changes over time, like global distributions. But then also see events, like COVID happens, right? And in January in February, people search very differently than in April, right? Just because there is some big event happen. And so for every business, you have these events which change, affect data distributions a lot, user expectations a lot, and it's very important to monitor and find those changes. And if needed, retune models, if needed, to create new training sets, testing sets to get this. So those data changes are very important. Data quality issues, right? Sometimes you have you have your NLP model, it runs well on your training sets, you get a new data provider which has some problems with data, and how to detect this and to be affected that will not affect your model, both from training but also inference time. System performance, uptime for every part of your NLP systems, biases, compliances, fairness, another important, very hard to build for high fairness evaluation, but it's very important part. Compliance, of course, significant changes, outliers in data, those kind of key monitoring parameters you always want to build a part of your NLP systems to detect those changes, like to rerun, to retune, to build new systems if needed sometimes, right? And of course, to do this, you need continuous monitoring, alerting, logging, and so on. Building NLP systems, there is abundance of libraries now. Again, anyway, you will never build just on them. You have to build on your own, but there are different. Sometimes you want to build before deep learning systems because many of those are super efficient, super fast. Like SVM classifier can be quite good for many tasks, right? Maybe you can build little bit better with deep learning, but with SVM you can solve a lot of really tasks well. So there is a lot of big set of open source for good old technologies. There are, of course, new technologies, right? Hanging face transformers, embraced library for a lot of really different models. Fast text, right? Good for some scenarios. NLP to build lab environment. PyTorch NLP, Flay NLP, detects from LinkedIn. So there are NLP libraries for many of those. A lot of academic open source available like you have to tune industrial environments. But if you go through papers with codes, like question answering, there are a lot of people build good systems and so on. And then high-level libraries helping to build end-to-end solutions for some domains. Teams for NLP. Typically I've noticed sometimes people building NLP systems emphasize on science. No, engineering I think is crucial. No one can do it without good engineering. So strong engineering, science, and product management are required, right? Now, like you will never build it without actually you can do something without deep learning, but there is a very big advantage on deep learning methods. So you need to build experts on this, but also you need like how to build and productionalize this and build MLOps for this. It's very important part of team building. And of course, high investment into engineering culture and so on. Data trend sets like NLP models, resharing them. Sorry, I'm quite in time. And then building continuous improvement time. So I've noticed sometimes businesses think about NLP is that you build something, you launch it, move to the next one. It's never ending operation. You need to build a continuous improvement cycle to improve, right? And it takes a lot of time to build advocacy for this, to convince your business leadership to invest into this. But it's very important that NLP systems are never final solution. It's always continuous solution. Always you need MLOps is a big part of this, to build this continuous improvement circle. And it's very important big part to improve build this circle to continuously improve the systems. And basically conclusions that NLP systems currently bring big significant gains to business and customer experience. Building them now is relatively, it's never easy, but relatively easy task compared to was 5-10 years ago. And there are multiple open source libraries, cloud solutions, alternatives, how to build systems within your company. And again, typically it's high return on investment if you approach it correctly. Yes, thank you very much. I finished.
Okay. Questions, Andrei, or is that fine?
Yeah, I have some time. I would be glad to. Thank you very much.
Fantastic. Okay, so first question is, how do the different kind of cloud offerings in terms of AWS, Azure, Google Cloud, how do they compare in terms of like the NLP maturity, in terms of the maturity of their products and kind of performance, that kind of thing? Can you comment based on your experience?
I know that, so I'm not big expert on Azure, so I know they have a really good NLP team there, and they deploying a lot of solutions because I see a lot of friends publishing something, but I'm not really expert what happens inside Azure ecosphere. I know that AWS and Google compete kind of on the comparison to each other. I believe Google has some advantage now in sense of type of models you can do there, quality of some NLP services, there were several comparisons that Google transcription, for example, from voice to automated speech recognition is better than Amazon, right? There were several open publications when the teams compare a really good comparison in details. But Amazon, I believe, is better in sense of building engineering, how integrate with multiple systems. And they have also quite good machine learning infrastructure to serve. They have AWS Batch. They have again, different things on AWS. And I'm not expert now in Google. From Google, I used a lot of when I was there, right? But I don't know really what happens into deep details with Google Cloud. From my experience, AWS has quite mature set. Certainly they don't cover everything. You have to build a lot, but I had really good experience using AWS.
I see. And in terms of kind of let's say trade-offs between kind of building from scratch or building custom versus kind of managed service, how do you let's say, is there a transition point in terms of the beginning of the state of the company or the product? Maybe sometimes for fast prototyping you start out with a cloud solution and then you transition to maybe something more custom to save on costs. Can you in your experience, what's that been like?
Yeah, it's a really good question, right? So what I found typically, NLP solutions, what I said in Google, Amazon, AWS, Walmart, we use them since 15 years and more, right? Many other businesses is something new for them, and business is not aware what they can get out of this, right? When they are not aware about NLP, it's very hard for them to ask for a big investment. So at this point, it becomes very important to prototype fast, prove value very fast with very small investments, two people see it, create a systems, prove the value that it serves business well, give money, and then you can get investment for get more people, right? And so for this, certainly like building cloud native like solutions is super good, super efficient, because you can build systems very fast. Like it costs a little bit more expensive to operate, but like like still operational costs are not that huge, right? And typically from this like time, yes, a cloud native is the fastest approach with minimum cost, minimum number of people, build something very fast and prove the value for the business. And then once you do this, you can get more investments from business, more understanding that they want to scale this, and you want to build your systems which will be much cheaper to run, operation costs, more scalable, and so on. At this moment, like yes, you move to some like it does not make sense to build everything from scratch, right? It will have very hard to build something like this particular Amazon service. But you rebuild a lot. And building your system from the beginning from blocks such that it's easy to replace them with custom is very important to put this design at the beginning, that this system can be transitioned into a new architecture.
Fantastic. So some kind of modular system where when you want to scale, you can kind of swap out the unscalable parts, the parts that are kind of very expensive.
Exactly. Yeah.
And then in terms of kind of the pipeline itself, do you find that, let's say like with Hugging Face Transformers library, you can bring in latest papers from, a lot of times papers that are implemented using the library, so you can import it directly into your code. So do you find that it pays off to kind of constantly be updating with state-of-the-art kind of models, or is there somewhere else, let's say like the data sets, the annotation, other parts of the pipeline that are actually kind of more valuable but are not like algorithmically kind of improving it?
Yes, it's a good question. As you know, right, some like if you go and look into state of the art for many current papers, right, typically improvements like you have 93% state of the art, and then someone makes 93.5%, right, so 0.5% more, and they publish it everywhere. It's not so important for your business, and typically it's like it's just for this particular, but you have hundreds of other models serving the same task, and if you improve one of those for 0.5%, it is not so big, right? Some of models is important to start with high baseline, because high baseline is really important. But overall, like filing the most recent papers is not important for all tasks. It's important for some very crucial tasks, like automated speech recognition, right? If you improve a little bit, because there are like tens or dozens of other models on the output of this model, then you improve everybody. This is important. But overall, if you consider whole NLP operations, following for every small incremental improvement, because state of the art published in some conference does not pay back from business benefits point of view.
I see. And I guess in terms of kind of prioritization, let's say you have like for chatbots, you have there's a lot of diversity in terms of kind of English speakers, the style of like the kind of the style of the text or the speech that's kind of being processed. Is there, how do you kind of serve these either multilingual models or multi kind of style models? Like how does that kind of aspect of like the system design work, where you're kind of there's a lot of kind of diversity or variance, let's say, in terms of like the data?
Like this task appears like in very different serving scenarios. Like one will say dialogue, like another is like for search engines, right? As I understand correctly, right? Do you want to have one model which understands this encodes inside of its network and then do something, or do you want to have some classification before, which decides what type of user or what type of antenna then runs particular model? And what I found, it really depends of your, like in some cases it's sort of kind of build model which will encode this inside, right? In other models you want to build classifier, because processing is so different, like can be very different what depend on user intent. You may have not just different NLP part, different like user experience part, right? So those really depends on particular use case. So there are multiple different ways how you want to process this.
I see. That's I guess kind of as a last question, in terms of kind of the pipeline design, you said there's a good mix of, let's say, old good kind of algorithms that still work, SVM classifiers, that kind of thing, versus kind of like these new transformer models. Where I guess is there kind of a trade-off between kind of latency, cost, speed? Like, what is the trade-off? Like, what is the calculation when you're kind of choosing to kind of design a system around like a very new kind of deep learning technology versus kind of old system?
Yeah, this is a good point, right? So yes, certainly, typically for neural methods, yes, you have quite long latency times, even with all optimization on GPU, right? You still get like this, like 100 millions parameters. Neural network will be having long time, right? Again, depends on tasks. There are a lot of optimization methods, distillation, which improves your times 3 times, right? Frequently, but not good enough. While if you train, let's say, logistic regression, right, which is basically just almost linear formula with a little bit more, it can be super fast, right? So latency is frequently the most important, which dictates do you want to go to deep learning or you want to do, of course, also some other like training size, right? For deep learning, it requires quite a lot, but then with transfer learning, we solve a lot of this. But latency is typically the most parameters which decide what type of models. Do you want to go to classical methods or do you want to use these new methods? This is typically like a deal breaker.
I see. So it's kind of like more online real-time systems, like if it's kind of like autocomplete within search, kind of thing that requires kind of lower latency.
Right.
Okay.
Yeah, and speed of training also important, right? Sometimes like not
right.
But speed of training for some tasks you can like tolerate 5% of loss in performance of accuracy of your model, but if it trains like 100 times faster, so for some tasks it's maybe more important to have faster training. So it really depends.
I see. Right. Sometimes you're updating the model more frequently, and or there's kind of like you have lots of data. Okay.
Exactly.
Well, fantastic, great, very insightful presentation from your years of experience. I hope the audience really enjoyed it. I certainly did. Thank you very much.
Thank you very much. Thank you very much.